Our dear friends in Taiwan and also Vietnam, and also our friends in the industry participating in our meeting through YouTube. Today is an online meeting. We hope that through our meeting today, Taiwan and Vietnam will have further cooperation exchanges in terms of smart manufacturing. Allow me to introduce our participants in Taiwan. The first is the Deputy General Manager Jianfei Zhang of CPC, and also Mr. Homo Lin from CPC Taipei. Please wave. And then Mr. Liu Yuyan, working for CPC Taichung, and Mr. Bob Chen from Siemens, and also Mr. Randy Wong, Manager of Business Management Department of CPC, and also Yizhang Cai, Manager Yizhang Cai of CPC. And also Bore Lai, our consultant in charge of technology. Now I'd like to hand over the microphone to Vietnam. Thank you for your introduction. Now I'd like to invite Deputy General Manager Zhang to give us an opening remark. Dr. Hip, our friends in Vietnam, good afternoon. Because of COVID-19, I regret that we cannot have the exchange in Vietnam face-to-face. We have to do that online through video conference. We have 3 special programs or sessions under the instruction of the General Manager of CPC. We hope that we can still enjoy the sharing of iBench know-how with Vietnam on a real-time basis, and maybe later we can talk about the fastest way to allow our friends and enterprises in Vietnam to also benefit from this exchange. And also we have invited representatives from Siemens. They will share with us regarding their expertise regarding the automation in factory operation, leveraging their experience in promoting Industry 4.0 in the US, in Europe. And our speaker is working for Siemens in Taiwan, and he is in charge of this relevant field. And also Mr. Wong, we have a special project called Digital Streaming and AI, and it's a very important element or a very important project for smart manufacturing. It's one of the projects associated with smart manufacturing, and Mr. Wong is going to share with us his experience. Now, I think we can start our meeting today with that in mind. Is that okay? Thank you. Now, I'd like to invite Dr. Hip to give us an opening remark. Then we will start our program today. First, I'd like to invite Deputy General Manager Zhang to give us the first keynote presentation. Good afternoon. My topic today is something that would be announced at CPC on November 6th, which is LSM, which means a lean smart manufacturing. LSM will serve as the foundation so I think I'm sharing the material ahead of my scheduled presentation with our friends in Vietnam. In the past, we have different progression processes all the way to IoT, and then we can adopt a step-by-step approach. However, internationalization is taking place very quickly. So lean management, visualization, digital connection, all these steps should be promoted at the same time. We cannot have a more step-by-step approach anymore. Particularly in the face of post-COVID-19 era, facing confrontation between US and China, we have seen very great changes in the market. So smart manufacturing should be promoted together with lean management. We know that Dr. Hip was educated in the U.S. He is very knowledgeable about Toyota-style management. So lean management actually was derived from Toyota's management style. And if you see the right portion of the slide, which is about the application of technologies for smart management of factories. And then, under the efforts of CPC, we have we have aligned the objectives. We have set the 6 major objectives. Like I said, Dr. Hip is a PhD. He is a doctor. He obtained his doctorate from Japan. And then for the first is automation, and then visual management. and the second is real-time report, and the fourth is factory networking, and the fifth is digital combat information real-time response, and finally value connection operational innovation. Now, for the interest of time, let me give you the highlights of my presentation.
Okay, so first off, I'd like to talk about visualization and automation. So in the Toyota manufacturing system, automation is actually used in abnormal situations. That is, when unexpected occurrence happens, the production line can immediately detect the occurrence and stop automatically. Therefore, you do not need highly skilled operators to detect the error or skilled technicians to save the production line from going into a standstill. This is automation, but the point is, how do we implement it? In the Toyota manufacturing system, it was implemented in a more rudimentary manner. That is, they fixed the amount of input to that of the output. So that was the foolproof measure of the Toyota manufacturing system. That is, by introducing only the fixed amount of input and raw material, they'll be able to control the exact output. And by controlling the flow, then they will be able to measure the productions and the execution. I think this is something that Dr. Hip is very familiar with, especially when he was working on his doctor's degree. But how do we take this one step further? We wanted to combine this with smart manufacturing and smart machinery. That is, instead of using simply a measurement style to foolproof the system, we wanted to use sensors and other devices to assist us. If Dr. Hip can come to Taiwan, I'd be more than pleased to share with you our model and the actual devices. That is, in the past, we used a measurement model, but now we can use sensors to measure the dimensions, the vibrations, etc. And this will be like a real-time taking of all the measurements. And it's able to replace the human effort. In the past, humans were required to carry out TQM, as in the Toyota manufacturing, but now we're actually using sensors and devices to replace the human effort. And if the system detects any abnormal situations or anomalies, the system would be immediately notified and it can be dealt with right away. So if you look at the past practices, both Japanese and Taiwan companies use worksheets like this to note the abnormal situations and errors. However, oftentimes these worksheets were filled in at the end of the day, and management would be able to learn about it only on the next day. So this would cause a time difference and a lag. But with the current system, everything is reported in real time, and there's no need to wait for people to fill in the worksheet and for people to submit the worksheets. So measurements we can take would include, for example, abnormal sounds, vibrations, temperature readings, for example. And so what can this, how is this data presented? We call it the Kanban. Kanban is like Japanese for a dashboard. And we put this information on a Kanban or a digital dashboard. From our observations, the information from the production line is often not readily seen. But with this Kanban, then the management will be able to have a clear picture of the amount of raw material required, the amount of output that's currently being produced, and the current yield rate, etc. So the Kanban or the dashboard would be where all this information is shown and where the management would go to find the information. So we call it actually a smart Kanban. In the past, it used to be on paper, but now we can put it on a screen. For example, this company is one that's located in China, and this has already been implemented on the floor. The management would be able to see all the production lines' current status, including the work orders that are currently being processed, the amount of raw material that's required for each production line, etc. So this is the concept of a Kanban that's transferred from paperwork to a digital format. So this is actually the floor of the factory, or the factory floor. We can call it actually like the storefront. And in the warehouse or the storefront, would be able to keep a record of the raw material. In the past, these are all detailed using paper cards. For example, people would remove different units of raw material and write down on the cards how many units were removed and how many is remaining. But if we digitize it, then this can all be shown on the smart Kanban, and this would no longer require the workers to input it manually. So for the smart Kanban concept, basically, I would like to make a comparison here on this slide. That is the traditional Kanban and the smart Kanban system. Now, the traditional Kanban system is actually quite ingenious, as they did not have this technology at that time. So they used the different management processes to manage and to make the production flow more efficient. But now with new devices, in the first, for example, we can now visualize the entire manufacturing process. And the amount that's inputted and the amount outputted would all be recorded by the system. The dashboards or the Kanbans can also be mobile. And everything can, and the workers management can use access cards to access the information. And these Kanbans would then actually show the information that's required. Next, I'll talk about the visualization implementation. The Toyota system actually mentioned 7 areas where waste could occur. For example, the excess production, waste occurred when waiting, transport, etc. And these are the 7 areas that waste might occur. And so in the traditional TPS system, we have the traditional methods. Of course, to prevent excess production, they use fixed volume and fixed input and fixed output methods to control this. For example, to prevent time wasted when waiting, they use light signals to manage the production line. If you look at this waste and storage, for example, they would also use a manufacturing Kanban and a supplier Kanban. But these can all be included and shown in the smart Kanban when they are digitized. If you look at the picture on the left, you would see actually the Kanban system in a Japanese factory at work. They, as you can see, they're in paper format, and the information can easily be shown on a bulletin board, but it's still in paperback format. And as you can see on the lower left, these would be the light signals that would tell the workers and management whether there's a shortage of raw material and whether the production is going on fluently. But as you can see, this would still require a significant amount of human labor to be in order to record and relate the information. But if we digitize the data and turn it into information, everything can be shown on the smart Kanban or the smart dashboard. As you can see from these slides, this is an example. And you can see the reason why we're seeing fluctuations here is because of the manufacturing rate at each production line is actually different. And therefore, we'll be able to look closely at the efficiency of each production line, and we'll also include the efficiency of the human labor that's involved. We'll also be able to immediately detect the yield rate, and if a production line is more prone to making faulty products, we can pinpoint the situation and look into it. This would translate into higher OEE, since the utilization rate can also be easily shown and analyzed. We would also be able to integrate the work schedule of the workers more easily with this system. The system can also be shown on mobile devices. The management will be able to have understanding of the floor on their mobile devices directly. I think what's most important is to prevent waste in human resources, in raw materials, and in terms of time. Next, I'd like to talk about the factory network. We've been talking about Industry 4.0 for quite a while, and we talked about 5+2, and now we're talking about the digital transformation and digital optimization. So what exactly is digital transformation? Basically, this refers to a linkage between the supplier and the demand side. And the purpose, of course, is to create customized products. I think I've shared this with our Vietnamese friends in the past. That is the ERP and MES linkage system. This can be used to replace the traditional Kanban system that relies on light signals to relate information. The upper right shows the Kanban box, and this is actually a management system used by Japanese companies in the past. For example, in these pictures, the information is recorded on the whiteboard by hand. The light signals and bell signals are recorded to show the current status of the production line. So that's the traditional Kanban system, and this was used to collect and relay information. But nowadays, we talk about using set-top boxes and on-site devices to collect the information, to transmit the information through the SCADA system into the MES. So for the linkage that we're currently talking about, our aim is to be able to trace each and every work order. For example, if we have a work order 01, we will be able to trace the current status of the work order. For example, if it's currently at DRC02, and we were able to trace whether the work order is fulfilled or not, and combine it with the CRP, the operating system, the equipment system, and everything will then be interconnected.
So in this way, we can set up a comprehensive networking system for our equipment. Now, for visualization of digital networking, we want to be able to monitor the on-site or the production situation remotely. Let me give you an example. For example, I have equipment in the remote side. We have level 1, OEE level 1, level 2, or level 3. For level 1, it means that for a factory, we can understand the overall factory machine condition. We can monitor the overall situation. I can understand the utilization rate currently. For level 2, level 2 means that I have information about the status of every single machine, its utilization, its performance. Level 3 can monitor all the parameters so that the machines do not have any defective products. Now I'm going to talk about something that is currently being discussed in Taiwan is C2M or C2B. What's C2B or C2M? What does that mean? That is, there should be a connection between commercial and also business aspects, and this is initiated by the customers. In the past, for products, they need to go through branded companies, manufacturing, importers, transportation, shipping, all the way to wholesaling and retailers. According to my experience in providing consultation services to companies, actually, I know how the prices are quoted for massive customization. The production should be linked with the customers, and the process has to be initiated by the customer. So we need to decentralize. We need to remove intermediaries, and also we need to provide sufficient information, and networking is also very important. For the commercial and also the manufacturing aspects, they have to be perfectly linked. In order to do that, we need to focus on the people aspect. We need to consider the taste of consumers, and the customers should have very clear information. And also, we need to understand the consumers. In Taiwan, we help a company that manufactures dresses, and for girls, I think it has greatly customized its operation. For apparel business, actually, different people have their have different dressing styles, and whether they prefer pockets and also the sleeve styles. You need to understand the basic information, the patterns, the color needs of the users. And then we can figure out ultimately whether laces will be needed in the end products, and whether the buttons and also the pockets are needed. But according to our experience, this kind of information is very important. However, for in the manufacturing process, you need to prepare materials, you need to engage in production, and the products have to be delivered to the consumers, because the consumers may need the dress because they may need to attend a wedding, they need the dress in time, so we need to deliver the products to the customers in time. So we need to address that aspect as well. In order to achieve that, I think we need to pay attention to distribution. We need to pay attention to the process from online to offline. if information is not shared between e-commerce and physical stores, then you don't have an integrated distribution channel, but rather you have diverse channels. They are not integrated. I'd like to come to my conclusion. When it comes to digital technology, I think we need to link the manufacturer with different aspects of business operation. During the pandemic, I think Dr. Hip and I had exchanges through Line. I told him that during the period of time we cannot travel overseas, and the CPC's consultants, including Mr. Lin. In the future, I think we will present smart Kanban or smart dashboards to help enterprises to embark on the journey of smart manufacturing. If you have money, you can buy smart factories. However, smart manufacturing involves integration of many different manufacturing elements in order to succeed. That concludes my presentation. Thank you, Deputy Manager, General Manager Zhang, for your sharing. Now I'd like to invite the next speaker, Homo Lin from CPC Taipei. His topic is assessment of productivity, again, iBench 4.0 for smart manufacturing development. Let's welcome him. Can you hear me? Good. Good afternoon, Dr. Hip. I'd like to send my greetings to our friends at VMPI as well. And also, ladies and gentlemen, good afternoon. Deputy General Manager Zhang, good afternoon. I think this is a cooperation occasion, and I was asked to say something about iBench. This is the outline of my presentation. Now, this slide is about the key challenges facing enterprises. For example, more varied orders for smaller quantities, and that's the current situation. Before 2025, you can see this kind of trend, and that's why we developed this tool in order to accommodate the needs in the future. In the beginning, when iBench was launched, we consider Industry 4.0 in Germany. It involves the setting of production plans, and also we try to promote some international standards. And there are 6 dimensions for the Industry 4.0 readiness indicators in Germany. There are 6 dimensions. I know that my presentation is very lengthy. Maybe I can only cover the first part of my presentation. I have more than 40 slides. Maybe I can only cover maybe the top half or the first half of my presentation. Now I'll talk about the readiness assessment. Actually, I have 2 colleagues sitting next to me. Next time in September 23rd, during the APO event, this topic was shared as well. I also understand that many member states are very interested in iBench. If you want the presentation material, the organizer, Deputy General Manager, will provide this presentation material after the meeting. There are 4 dimensions I'd like to talk about. The first dimension includes Fourth of organizational strategies, the second fourth smart manufacturing, and then smart driver, and the fourth of innovation value.
那我们在做这些对应的一些方法，
Regarding the corresponding methodology, for example, crowdfunding, sharing economy. For the second portion, IoT or internet, etc.
更重视流程间的一些连接，
And also emphasis on inter-process or cohesion, such as subtraction, addition, multiplication. Regarding automated data collection, we use RFID and automated sensor technologies. And also it involves learning. And I'm going to go into details about these aspects.
那现在参与的部分也可能也也有听过这个部分啊，那没关系，讲说我们在这个部分在希望逐渐推广到。
And we would like to promote certain aspects here. So if maybe VMPI can try out our platform in the future, and I'm going to provide my contact information in my email, and then if you need to contact me, you know how to reach me. I hope that you can also try out this platform.
好，那我介绍一下，我们大概我们的监控可以
Let me introduce the dimensions of our assessment. Regarding the first dimension, which is organizational strategy, it has four components. The first is visionary leadership. The second is strategic planning and operation management and human resource. It's part of organizational strategy. For the second dimension, which is about smart manufacturing, and the items include the preparedness or the readiness of smart manufacturing. It covers lean management, smart manufacturing, smart service, and also performance evaluation. The third dimension is the drive for smart technologies, including the software corresponding to the current manufacturing operation in factories. For example, smart ERP systems. And the second is linkage with external system. For example, whether CRM or SCM is introduced. And the third element is mobile business computing. And finally, it's about cyber physical integration. The fourth dimension pertains to value innovation, consisting of innovation blueprint, innovation process, innovation model, and innovation culture.
好，那信不信在你
Wait. Oh no. Someone probably pushed the wrong button.
OK，那我们在讲哦，我们这个所有的底下有个特殊的地方，帮我切到11页。
Please switch to page 11, or I can operate my slide on my own. It's frozen. I cannot control my slide. Can someone help me out with the control of my slides? Well, let me continue for the interest of time. In the course of our assessment, we consider the aspect of perception and also the aspect of implementation. But you may be aware of something very important, however, you may not be able to carry it out due to budgetary constraint.
提向过
That is, at every stage, we would like the company to have understanding of their current understanding level and implementation level. So this is a constant self-evaluation. So if we come to this slide, you can see that during our design, we also change the weighting a bit for each dimension. For example, for organizational strategy and value innovation, we've assigned 10% and 20% respectively. The two center dimensions, smart manufacturing and drive for smart technologies, would be the key components of iBench. So you would see that we assign them a higher weighting of 30 and 40% respectively. So for each dimension, we have the operational definition. And you can see that the operational definitions are given on level choices 1, 4, 7, and 10. If the company picks 1, it means it's not understood. If it's 10, it means the company is fully proficient in this ideal concept, with 4 being partially understood and 7 being fully understood. So in the online assessment, the user can simply move the bar to select the levels from 1 to 10. What I'm showing is the iBench in Mandarin, but we have already translated it into English now. So if you log into the website, you'll be able to see it in English. What's unique about the assessment is that you can immediately see your current status compared with others. If you look at the graph on the left, you'll be able to see your current standing compared with others who've also taken the assessment. For example, you would see the leftmost bar being the maximum score received currently in the data bank. You will, of course, not be able to see which company it is, as all the names have been removed for the sake of confidentiality. But we will be able to get, for example, the maximum score, the minimum score, the average score, as well as your score, which would be the bar on the right. And this would give the company that's doing the assessment have an understanding of its current standing among its peers. Here we have a radar chart that maps out all the scores in each dimension. And this gives the company a better idea of the areas they are doing well and areas that may need more improvement. You can also check out the comparisons with other companies as well on the radar chart. We would also be able to get a ranking among all the companies that have taken this assessment. As I've already mentioned, you would not be able to decipher which company, which data belongs to which company, as we've removed all the names in order to preserve confidentiality. And finally, we also have a readiness reference indicator to give you a very straightforward score in terms of Industry 4.0. So this is basically used as a reference, and it can create easy buying from the company side. Well, what I'd like to mention here is the assessment should be viewed from a comparative perspective. That is, everything is comparative and every area has room for improvement. What I mean is we would have this chart at the end, and the assessment actually encourages constant improvement. It's not a final score, but a comparative score of awareness and implementation. From this chart, for example, we have awareness on the x-axis and implementation on the y-axis. So if we look at the upper right and lower left, on the upper right, we have high implementation and high awareness, whereas on the lower left, we have low implementation and low awareness. From a consultant's perspective, of course, what we needed was a tool to carry out analyses, and that was what we had in mind when we develop the iBench. It's meant to be used by consultants to have an initial picture of the company so that the consultants can know which area should we work on first. The dimensions or the scores the company gets would likely be scattered among this chart, and the final goal, of course, is to have them all move towards the upper right corner. Would also have readiness levels, but in stages. The company can also take this to assess its current standing. And this is just a follow-up. Once the scorecard has been filled in, the company can fill out the action plans based on short-term, medium-term, and long-term projections. This is also a similar practice. That is, after doing the assessment, the company can roll out improvement plans. This would include, for example, confirmation of the program, plan execution, introduction of external resources, implementation of the actual program, and sharing of the achievements and indicators. Of course, the company would have different goals to achieve at each stage. And after, say, for example, 6 months, the company can take the assessment again to check if they have improved. These are companies that we've worked with in the past, just to give you a brief picture. And since we have limited time today, I would not be able to give a very brief introduction of the iBench tool, but I would do encourage you to try it out yourself. Understand our friends in Vietnam is interested in the system, and I do invite you to try out the assessment yourself by logging onto our website. We also have some additional reference material for you regarding the tool itself. I would be skipping these pages in the interest of time, but if you have any questions related to these following pages, do feel free to contact us. We will be pleased to provide answers. We actually have a contact here, 03187@cpc.tw. And if you have any questions, feel free to contact me through, or contact us through this email, and we also welcome any feedback. Okay, are any questions so far? Okay, thank you, Director Lin. Okay, allow me to add a bit more information here. On October 6th, our general manager had a meeting with us. Dr. Hip has expressed his interest in iBench, and we have reached this consensus and so signed an MOU. So that would be a starting point. And since we're able to share information online and meet online, what we can do is to set up a team of seed experts in Vietnam, and we'll be able to transfer the knowledge to this team of experts. They would then be able to work with local companies and have them carry out or take the assessment tool to try it out. And we hope that this tool will then be able to be actually used and benefit the companies in Vietnam. So this is just a follow-up from the meeting we had with our general manager. Okay, thank you very much. Next, we would like to invite Mr. Randy Wen to share with us his experience in setting up smart factories. Okay, Dr. Hip, our friends at VMPI, I'm Randy. I would now like to share with you our experience in building a factory that uses the smart manufacturing concept. This will be the outline of my presentation. I would start first with the problems we encountered at this company, and then I would explain what kind of project we devised after learning the key issues that they have experienced. I would then be sharing the structure of the project, giving a description of the project stages, and finally, what benefits the projects provided to the company. First off, this example is a company that manufactures elevators, and they're considered a small to medium-sized enterprise. This is a very traditional company. The reason I say it's a traditional is because this company basically only uses fax or email or phone calls to communicate with suppliers. The information is then recorded on paper, but oftentimes these paper records might go missing or the information might be misinputted. Therefore, when we approached them, it was clear that the communication between this company and the suppliers was not digitized at all. And this would cause a gap in terms of the understanding between the two parties. And this would also cause a long gap in terms of the communication and the supply flow. So it is oftentimes that they would need an inventory capital of at least about 50 million to compensate for this. Secondly, elevators are built per commission. And after the elevator is built, of course, it would be used by people, but no one knows when the elevator system would break down. The users, buyers, would usually have no way to repair the elevator themselves. And since they are unable to know when the elevator would break down, the company will also be unable to know when they should prepare themselves to provide maintenance. Of course, elevators need to be safe, and they need to meet certain safety requirements. So the users also need some form of guarantee from the manufacturer. So this is actually an issue that the company faces, as they're not just providing a product, but a service that is closely linked to the safety of its users. It's also actually a form of social security, or it needs to offer a sense of social security for the users. So the company wants a way to predict when these elevator systems will break down so that they can prepare themselves, have all the inventory needed to carry out the maintenance or repair work.
部分就
consisting of A, B, C, D, E portions. A is about supply chain information. And for this portion, we set up a supply chain information streaming platform. We set up the platform so that the sharing of information between different vendors will be easier. The second is about central controlling platform of smart factory, and we will be able to link different production information, and then we can proceed to the concept of networking of equipment. And after the equipment or the machines are networked, we can set up a database, and then we need to have a Kanban or a dashboard in order to present information for monitoring the relevant processes, so that we know that whether we are on schedule for a particular aspect, and you can also detect if there's any irregularity. And for the products, elevators, we can set up a black box, and the black box can collect information and data. And after the data collected, we can analyze the data so that we know certain parameters are more relevant to elevators, and we can know early on when maintenance will be required. But how do we derive the models? We need to leverage AI algorithms. So we need to have our central control platform, and also AI black box and AI algorithm and calculation. And all the information has to be linked. And more importantly, we need to have the portion E, which is about safety or security, cyber security management. We need to protect our system against hacking. We need to ensure the security or back up the security of our company's information, or to back up the corporate information. Now, let me describe the overall project. We hope that through their internal and external processes, and also after-sales services, we can introduce all the pertinent information. Ultimately, we hope that we'll be able to transform manufacturing into a service process. Now I'm going to go into details about the components. The first is about a supply chain information streaming platform. As you can see in the central part of the slide, you can see an information platform, and it links information about raw materials, and if there is a shortage of materials, or we need to replenish the raw materials, or we need to replenish our inventory, we will proactively contact the suppliers. And the suppliers can also leverage the platform to provide their quotes. And then through our internal electronic processes, we'll be able to procure the products from the vendors or suppliers. In the past, we used paper-based operation, but currently, we hope that we can use this kind of information-based approach so that we can avoid the missing or the loss of information or the omission of information, so that we'll be able to control the schedule for the procurement of raw materials. Also, in the platform, we also introduce a CRM system. with this CRM system, we can build relevant information in the system regarding customers and also suppliers. And also through the system, we can understand the process of providing quotations. We know how the process is being fulfilled. And also, for the system involving the maintenance of elevators, we can use such a system as a tool. Through the tool, we can gain a comprehensive understanding of all the service or maintenance records and the service records, and they will be quite visible in our system. And then we can check the history of the customer's elevators by looking at the past maintenance records and by looking at the past failure records of the elevators. And now I'd like to introduce the BI system. It's a modular system. Through AI technology, we can incorporate the elements of our choice. I talk about the black box. Through a black box, the information can be sent to the CRM system, and then we can also use our AI and our BI tools. Through our algorithm, we'll be able to create an overall enterprise situation room. And this is quite important for managers and operators and owners so that they can make relevant decisions in the future. Regarding the B element or the B portion, under the category of A, I just talk about various pertinent tasks. Now I'd like to talk about category B. We want to introduce a council concept of system. In the past, we didn't do. It was not easy for us to control quality and also the process parameters and also quality measurement parameters. We could not obtain the information on a real-time basis. That's why it was difficult for us to optimize the process because of the data we had were not accurate. And as a result, it was more difficult for us to control quality. And also a lot of information was noted down in a piece of paper by the employees. So we had a lot of paper-based information with a lot of manual operation. So sometimes the information is inaccurate or information is omitted. And it's impossible for us to have an integrated system due to a lack of information, and we were not able to address irregularities on a real-time basis. So maybe through the networking of equipment and also through databases, we will be able to integrate the information, and the information can be integrated and put in the dashboard to provide visibility to managers or supervisors. Now regarding equipment networking, we identified two machines. We set up a power meter for the company, and we want to monitor the state of power consumption of their machines. And we also, the system can record the records. And also, for freight elevators or scenic elevators or passenger elevators, there are different controllers, and the controllers can be networked with relevant records entered into our system. And then this is the SCADA system. First, we need to establish a SCADA system. And also in their machines, we set up electricity meter so that we can obtain information about power consumption, and then the information can be provided or recorded in the database, and then we can monitor the state of power consumption. And in the lower portion, you can see the utilization rate of the equipment. If the equipment is operated normally, you can see green lines. If it's yellow light, Yellow means that the raw materials are still pending.
接下来就是说另外一个
Now, let me talk about visualization. In fact, currently, it's difficult for information to be archived and analyzed. So as a result, for maintenance of our elevators or customer services, we cannot plan ahead. So in the past, even there were scenarios where the elevators was a malfunction for 48 hours, and that was quite an impact to the reputation of the company. So we need to have a system like this. You can see there are 4 stages for this system. For the first part, we need to have a real-time display and system for elevator running status. And secondly, we need to display the major mileage records of our elevators. Whether the elevators have traveled upward or downward, we need to be able to see the trends regarding the operation of the elevators. And also, in the course of elevators operation, we also need to know the status of utilization of the elevators. And then we will have analysis chart indicating the operation of the elevators. So you can see 1, 2, 3, 4 different stages. Because this company has just begun the operation of this system, so I think we can only assign 1 star, and the best performer can receive 5 stars. So we are still helping the company perfect the system. In the lower left, you can see that on the home page, you can see the depiction of layout remotely. You can see whether the elevators are being operated or they are on standby, and also their current operating status, and also the mileage of each elevator. We can display such information. And also you can see that there are 3 elevators. For example, a passenger elevator, 1 scenic elevator, and 1 freight elevator. You can see the number of the minutes of operation which have been accumulated over time. You can also see the historic records, and then you could come up with charts or for statistical and analytical purposes. And this is the concept. This depicts the concept of a dashboard, and we can provide the dashboard like this in a situation room for the manager and the owner to understand the current status of the elevator's operation. We're talking about elevators. Elevators need to be maintained. In the past, oftentimes, we rely on a lot of paper, a stack of paper, and you need to check item by item in order to ascertain the status of the elevators. However, the paper materials are heavy, and also the inspectors, in the course of checking, oftentimes they do not keep very accurate or detailed records. As a result, the maintenance records of the elevators are not comprehensive. And it's very difficult to pass down information from inspectors to another inspector. And as a result, elevators' safety will be compromised. We hope that through the use of mobile devices such as tablet PCs or smartphones, our maintenance personnel will be able to use a tablet PC or a smartphone to check the safety of the elevators at the customer's end. So through this kind of platform, we can help the company. We need to teach the company how to operate the system. So we provide our education and training, and after that, we launch a system like this. And this slide depicts the structure of the maintenance of elevators. And this is really a more important slide than the previous one. But how do we operate a cell phone or a smartphone or tablet PC to conduct maintenance? Now, the first thing is that the customer will issue an order, and then when the order is issued, the relevant basic information will be provided. The customer will indicate the categories of maintenance or the date of maintenance, and each elevator has its ID, and you need to show the ID of the elevator, and also the issues that the IT currently has, and the issues have to be clearly described. The customers can provide the information, and after the information is provided, our service staff and also our salespeople will obtain the information and discuss with the customers.
这个问题
They will then contact the client to see if the issue is indeed as they have put in. They would confirm the situation, and if it's still within the warranty time frame, then of course this will be free. But if it's already outside the warranty period, then they would give a price quote and see if the customer accepts this. If it's accepted, then the order is then submitted to the superior and the company, and then the company will be notified of this work. The company would then assign technicians to carry out the maintenance or repair work. Of course, once the technicians receive this work order, they also have to get an understanding of what the problem is first, and they will then prepare the required material and components needed for the repair or maintenance. The technician would also be taking photos of the elevator before and after the maintenance or repair work is done, and that would be uploaded into the system for record purposes. Afterwards, the work would then be inspected to see if all the issues have been fixed. And this, if work order can only be closed once all the issues have been fixed. Therefore, this would be a mechanism to check whether all the problems that the client has raised has been covered. The technician or maintenance staff would no longer need to carry with them a huge stack of paper records when they perform the maintenance, and this actually would make them look more professional, as everything can be immediately checked on the tablet. So, to give you an example, if the MPU board actually develops a E001 signal, then the judgment would first be made, and the ways to resolve this would also be shown, and this can actually be seen on the mobile phone directly, and this is the same for other types of errors. So as mentioned, elevators actually need to be safe, and therefore health inspections also need to be carried out for elevator systems, as we do for the human body. The elevators have a black box that collects data during its operation. For example, this would include the upline running time, downline running time, the operating time of its brakes, frequencies, etc. And there also be, for example, brake contactor times, opening times, and closing times of the interior doors that also be collected in the black box. The electric current, voltage, temperature, and other electrical properties and data would also be collected. This would allow the technicians to analyze the current status of the elevator based on the collected sound and the vibration data. If the elevator is still looking good, then that's fine. But if there are suspicious areas, then a quick check or on-site check can be scheduled and performed to ensure the safety of the elevator system. System is also implemented at the company level. For example, you can see yellow lights, red lights, and green lights. Green lights mean the system is operating normally. Yellow lights mean maintenance is needed, and red lights mean that the system is currently down or the elevator is currently down. So this would also serve as a system to give the company a quick view of which elevators are operating and which are not. This can also be uploaded and integrate into the Google Map. Since elevators are usually located in various buildings, you can see from this graph that this is actually the ideal picture, as all 5 elevator systems show a green light, and this means all 5 are operating normally. On this graph, for example, we see 2 of the elevators requiring maintenance. So the management would then immediately be able to schedule maintenance work or repair work for these 2 elevators. This is, of course, situation 2. Now, this is a third situation that the management might see. And here we see red lights showing on the map. Red lights mean that the elevator system has shut down, and this requires immediate action. Next, I talked about having a black box in the elevator system. And by black box, I'm referring to something, as you can see in the lower pictures. The black box would, of course, have to be integrated with the AI system and the information system, as well as the central control system. Therefore, for the black box, we've also developed the controller and the required system. This is a picture of the black box that we installed in the elevator system. And this is actually a diagram that we will be pleased to share with you on how the elevator system was upgraded to include the black box. Here we have elevators for passengers and for freight, and the different setups. But of course, we've also made changes to the factory floor. As you can see, pictures before improvement and after improvement. We help them change the material flow so that it's more fluid, and that the motion lines are more straightforward. We also saw the issue with long transport distances in the factory, and by simply rearranging the workstations, we were able to resolve this. This is the basic 5S management that we did for the company on the factory floor level. For example, keeping safety distances and making sure that the gangways and corridors are free of stuff. The highlights of the projects can be found here, as well as the benefits. For instance, the customer downtime has shortened from 6 to 8 hours to 2 hours. OEE, overall equipment efficiency, went up by 10%. The inventory went down, the requirement went down by 40%. Per capita output actually went up by 123%. And the market share increased by 1.5% with an increase in turnover by about 210 million. They were also able to increase their supply chains by 15. And with this, I would like to conclude my presentation. Thank you very much. Okay, thank you, Mr. Manager Wong. Okay, hi, this is Deputy General Manager Chang. I'd like to add some more information here as well. Dr. Hip, if you come to Taiwan after the pandemic has died down, I'd like you to know that the manager or owner of this elevator manufacturer is actually my friend, and I will be pleased to show you to their company if you're interested. Okay, thank you very much. Okay, now I'd like to invite the speakers from Siemens to share with us the trend of training and development in digital factory. Thank you, MC. And I'd like to thank the Deputy General Manager for inviting us. Allow me to give a brief self-introduction first. My name is Bob. You have my CV here. Currently, I work at BHP Industry Solutions. I used to work at Siemens from 2007 to 2017. I was a project manager at Siemens as well. So I actually used this as the topic of my master's thesis when I got a master's degree at the Fengjia University. The topic was over the smart platform in Industry 4.0 and PL and how PLC can be used. So Siemens is actually a company that, and BHP are companies that companies in Taiwan are very familiar with. They are all members of the PI International, and we would share information on this platform. I also have a blog myself here at the bottom of this slide, and I would share my observations and experience. Blogs actually are very useful resources for people interested in PLC and smart factories. Well, my observation is that blogs actually can serve as the fuse or serve as the starting point if you want to learn about something here for this field. And with that, digitalization transforms everything. I think starting from 2018, Siemens no longer use the phrase Industry 4.0 because Industry 4.0 is not just a goal. Of course, people still ask me, how do we achieve Industry 4.0? But the point is, it's not a goal. That is, Industry 4.0 is just a concept. You cannot realize Industry 4.0. But how do we implement Industry 4.0? It's actually implemented through digitization and digitalization. That is, if the company is digitalizing itself, then this means the company is moving towards Industry 4.0. And this actually brings me to the concept that we are rolling out. So why is digitalization so important? If we look around us, you would see our world starting to digitize and digitalize. Traditional bookstores, for example, used to provide us with paperback or hardcover books. But we're starting to see less and less of these brick-and-mortar stores. People are beginning to read online or beginning to read the digital versions. We are still reading. Reading is still a habit, but we're now being more accustomed to reading e-books instead of paperback copies. And e-books actually allow us to collect information and understand what are the newest offerings quicker. So other than books, hailing taxis, for example, and our habits when using public transportation. In metropolitans like Taipei, you would likely see less and less people hailing cabs on the streets. Because if you want to hail a cab, people would more likely make a reservation on their cell phone nowadays instead of simply putting their hand up to hail a cab. So this is also another form of digitalization. And this also brings us to the industry of car sharing. So it's transforming our life and transforming every walk of life. And this also applies to the manufacturing industry. it doesn't matter whether we want to promote Industry 4.0 or not. Rather, this is an inevitable trend. It's not whether we want to promote this trend or not, but rather it's a trend that is already happening and is actually going to be here with us, whether we want it or not. So just a quick recap. We know the first industrial revolution was the introduction of steam engines. The second industrial revolution introduced the mass production and use of electricity. The third industrial revolution introduced automation and computer-assisted manufacturing, whereas the fourth industrial revolution is digitization and connection of different systems.
So, Industry 4.0 is not just about these technologies. I think the technologies are not directly linked with Industry 4.0. Even without Industry 4.0, these technologies still exist. Still, these technologies will be moving towards a high degree of digitization. So whenever when we are talking about automated robots, robotic applications, they will be highly digitalized. If I need to use simulations software, the software, of course, demonstrates a high degree of digitization. So we don't want to emphasize how advanced the technologies are. The more important thing is that the technologies are highly digitized. So when we are talking about the manufacturing sector, we hope that the the manufacturing industry is moving towards digitization. The higher the degree of digitization, the higher the realization, the higher extent the Industry 4.0 is satisfied or realized. Whenever we are talking about hardware or software, the entire process, the manufacturing process, will be more efficient naturally. So we do not just want to pursue improved efficiency of the production. So I think we need to understand that the goal is not efficiency. I think digitization is really the goal, and the efficiency is the additional benefit that you can receive as a result of digitization. So whether we are talking about a factory involving standalone machines or a large factory that involves a large-scale production, digitization is a path that you definitely would embark on. So in the course of our journey towards digitization, a very important focus is that you need to have comparable communications protocol, and also you need to have industry standard cyber security standards, and also you need to have industrial scale service. And ultimately, where is the confluence of the different efforts? I think that will be the cloud. The cloud is the place where all digitized information will be integrated and collected. And then we'll be able to achieve cyber-physical integration. So in our journey of digitization, slowly and gradually, we will integrate top-notch digital technologies. But the technologies are not our objectives. However, we want to pursue digitization. We need to use digitized products. So we need to use IoT and edge. And also we need to use artificial intelligence and also collaborating robots. And also we will use 5G services for cybersecurity. Of course, it's an element that is also very important, and also there's an aspect, the aspect of cloud, and also all the hardware that is currently in use has to incorporate all these ideas. So we gradually introduce these elements in our existing production environment for a small factory. How do you digitize? These are the 6 directions that you need to think about. For an existing large factory, you just need to enhance the extent of the application of these technologies. For collaborative robots like the slide depicts, for these collaborative robots, what kind of commands do we need to issue? I only need to indicate the products I want to create, and the robots naturally will help the engineers and the operators produce the products. Well, how different are such robots from the robots in the past? In the past, you need to show the robots how to produce the products. However, under Industry 4.0, we don't need to issue this kind of instructions. You need to describe the products that you want to create. So take Siemens, for example. How do I achieve this kind of autonomous handling system? A very important idea is that we need to make sure that such equipment can be integrated with upper layer source of information. This is what we call a vertical integration of OT and IT. OT means operation technology. That is all. That includes all operating systems. OT can be understood as all the hardware equipment that you can see, even a sensor or a brake is still a piece of hardware. All the way up, we were looking at the tool or the machine, is still hardware. So that's called OT. And the data generated by OT are provided to IT, which is information technology. It's more like software knowledge. So the data from OT should be delivered to IT, and the process is called MindSphere at Siemens. And MindSphere connects different domains. If you have a lot of equipment, regardless of what the equipment is, the most important thing is that the equipment should be network capable. And in the course of networking, you need to achieve a high degree of cyber security. After the equipment is network connected, you need to consider how subsequent services can be provided. And this is something you need to pay attention to in the networking process. So in the course of our promotion, we always say that this is a process of digitization. So a lot of people ask us how we can achieve Industry 4.0. We do not teach our people how to do Industry 4.0. Our focus is really digitization. We can start with something small. You need to assess whether you meet the criteria for digitization, and then you work your way up all the way to the cloud to see if the cloud can collect all the information below, and then at the cloud level, you can conduct big data or AI analytics. I think I will conclude the portion of my presentation. I'm going to hand over the microphone to my colleague, Linda, to continue with the presentation. Good afternoon. I'm Linda from Siemens. I'm going to talk about the aspect of digital talent development. At Siemens, talent cultivation consists of two aspects. The first is about industry, the second is about school.
先画面上看到，
As you can see in the slide, there are two different components. At Siemens, we have different personnel in charge of relevant work, including the curriculum development and also the development of teaching materials. In terms of the training for the industry, as you can see in this picture, when the engineers from different companies industry come to Siemens, they come here with the issues they have come across at work. So the most important thing is that they need to have a hands-on operation of real tools.
大概在18个小时。
And I think the training duration is about 18 hours. Each program lasts about 18 hours. And after they go back to their workplace, they will be confident in resuming their daily work. Through hands-on operation and learning,
客户他们来这边上课最重要的。
this is it will turn out to be the most important experience for these trainees.
那以这个班级来讲，我们有2个客户，
Currently, we have two customers
第一个他的工程师来这边
who have sent their engineers to attend the programs so that after the engineers finish the training, they will be greatly improved. In the past, they were unable to address certain issues, but after the training, and they realized that through hands-on experience, they will be able to actually address a lot of issues they come across at work. This is another example showing that we tailor-made certain training programs for certain customers in order to meet the customers' needs. As you can see, that this is a picture of the instructors. We train the trainers for the customers' training center setup. We also train the so-called seed trainers or instructors for the customers so that they can go back and offer training programs or provide training to their employees. In addition to our standard programs, we also have a certificate program for Industry 4.0.
在这个认证内容，他认证的不是
We are unique in the regard that we don't provide the certification based on their familiarity with the equipment of Siemens, but rather we focus on the knowledge that they should have from different. There are 3 different levels of certificates.
那个工程师来看，他要的是如何
Different levels of certification require the different levels of knowledge of logic and also system analysis.
那这样子的认证发展到今年也
Until this year, I think we have we have also developed a new programs,
包括用的很多软体，
and we will introduce a lot of new software,
趋势整个的课程。
and we will gradually we will come up with cyber and also physical integration programs. I just talk about the education training to the industries.
在这个数位化的这个浪潮当中，
However, we also seek to help schools set up relevant training programs in order to cultivate future engineers. Siemens is an official partner of the German government.
或者之类，西门子都会在当地这个
Siemens
要协助
work with the German government in helping students to obtain relevant qualifications so that they can participate in World Cup competition. Now, to go back to schools, how do we help the schools set up programs to prepare the students for Industry 4.0? In Germany, the efforts cover the training environment, the creation of training environment, the development of training curricula, including the curricula and also the teaching materials. So over the years, when we talk about Industries 4.0, including schools and different entities, they want to understand whether there is a systematic approach to train Industry 4.0 talents, from mechanical engineering, automation engineering to IT. We need to have systematic integrated programs covering different domains, covering basic education and training, all the way to the second level understanding in communication technologies. They need to be able to understand how to leverage communication technologies,
云端这个
so that they can have a better understanding of the cloud-based technology. Currently speaking, well, on the academia or training institute side, what they want to know about is how to cultivate these talents, and that these talents are indeed what the industry needs. So we have the 25 top competencies that Industry 4.0 companies need listed here. This would include, for example, the 5 categories in information technology, interdisciplinary knowledge, electrical mechatronics, business management, engineering, etc. And you can see what's most important is that the talents that the industry needs are people with interdisciplinary training. So for our work in cooperation with the academia, our hope is to have the students here in Taiwan truly understand what the industry is doing and what the industry needs. So we are working with the government in consolidating and integrating the type of education that we are providing students. We want to give students a taste of the industry while they're still at school, so that they have a better understanding of the talents required and the type of expertise they need to cultivate. This is the Taipei City Digital Talent Program that we've worked with the government in the past. As you can see from the pictures, students are actually able to have hands-on experience using the latest machinery and equipment actually used in the industry. We've actually also brought them to a short-term trip in Siemens, Germany for an on-site visit. And finally, the lecturers and teachers are actually the most important component in this lifelong learning. So other than providing training, we also want to make sure that the trainee can one day become trainers, and they'll be able to pass on the information and knowledge. So if you look at the pictures on the lower part, you would see students finishing their internships and receiving a certificate so that they can one day become trainers themselves. In Taiwan, we have general purpose high schools and vocational high schools, and they have different focuses. For the senior high school students, we also have an AI curriculum that would be designed differently depending on the type of curriculum the student is in. We want to introduce how artificial intelligence is used in the industry for the general purpose high school students, and to give them a better understanding of the type of talent expertise they need. Whereas for the vocational high schools, we want to allow them to have more hands-on experience so that they can be received well at the workplace immediately after graduation. The point here is to prepare the students for the future. We talked about the 25 competencies that the future workforce needs. The future does not need a person who is skilled only in one platform, but rather one who has interdisciplinary training and expertise. So with that, I'd like to end my presentation. Thank you very much. Okay, this is Deputy General Manager Zhang. If I may also add some more information. We've been working with Siemens starting from 10 years ago. Our cooperation covers the PLC, and recently it has moved into the virtual world. We also have a training center here in Taichung, and Siemens was actually the first company to participate and work with us in this platform. Siemens is also the first company to work with the Taiwan government on ICAP, which is a talent verification and certification program. Once this program has been passed, we will be able to work with Siemens to offer this license-based certification program. And in the future, we also plan to set up training centers under the APO infrastructure, and we will still continue to work with Siemens in setting up such training centers. Schneider and Banner from the US have also joined this platform along with 3 other local companies. So I believe with the support and assistance from Siemens, we will be able to roll out a platform that's as comprehensive as possible. And hopefully, this will be a suitable platform that we can use to assist our other APO members. So I'd like to thank Siemens for their help once again. Okay, thank you very much. I would now like to move into the Q&A session. I would like to invite representatives from Vietnam to share any comments or feedbacks or questions.
Okay, thank you very much. I'm here from Vietnam. The presentation is very nice and very useful for us. So before our team from Vietnam and also the enterprise and from Vietnam and so member from Vietnam have the questions. So may I have one questions? Yeah, related to the how to say the solution for smart manufacturing. So from the presentation of Professor Chiang, I would like to ask you that may we cooperate to prepare the project for how to say, so I mean demonstration project for Vietnamese enterprise. So our team, Dr. Longs, he's the head of innovation department here. So he will be the CPC prepare to support Vietnamese enterprise to apply some smart manufacturing solutions, such as how to say supply chain information platform, and also like some kind of machine maintenance solutions. Is it okay from the CPC? Just one of my questions. Thank you.
这个问题。
Okay, let me provide a response for this question. Okay, I think I should be the person to answer this question. Regarding cooperations with Vietnam, I would say has always been one of our mission targets and priorities here at the Center of Excellence under APO. Of course, we all understand that the pandemic has impacted us significantly this year, and the impact would likely go on until the first half of next year. So we would still be inconvenienced by the pandemic. But as I think Director Lee would also be sharing later, we have worked with a lot of Vietnamese companies as well, but most of them are still companies owned by Taiwanese businessmen. I have to be frank and blunt about this. For companies in other countries, for example, in Thailand or in China, we also have experience working with them and providing consultancy services. But most of these consulting services are provided on a case-by-case basis. It would be difficult for us to provide an overlapping solution to cover all these companies, as they may have different requirements. So if we want to take our cooperation one level up to provide a more comprehensive strategy, we might need to discuss this further and proceed in stages. For example, we can segment training and consultancy services into different portions because, for example, iBenching, consultancy services, and training are actually all different aspects of an overall solution. And I would, of course, be pleased to discuss further with you regarding the possibilities of such a cooperation.
Thank you very much. So my second question is because our new programs on productivity for SME in Vietnam just was signed by Prime Minister last month. So I also want to set up a project to bring 10 to 15 people from Vietnam to CPC and train with the smart manufacturing, similar the case in Thailand. So you remember? So can you give us some comment to prepare? We can prepare such kind of project and submit to our ministry. Thank you.
Yes, I think this is definitely doable. The general manager has actually allocated a significant amount of our budget on training this year. Although we were unable to receive participants from overseas this year for our training program, but as I just mentioned, we have been working with more international companies this year to consolidate and expand our training program. Companies like Schneider's and Banner, and they are now all integrated into our training platform. This is definitely doable. The case in Taiwan was they provided seed trainers, and that is the people they sent over are people who are expected to become trainers in the future. I also promised them that if they need our roadmap or, for example, equipment or even the curriculum, then we can actually provide this to them. That is, we can ship the entire curriculum to them so they can actually replicate the curriculum in Thailand. And that was actually something I promised our friends in Thailand, including setting up the training center, etc. So for Vietnam, we've actually have been in very good relations with Dr. Hip. Dr. Hip is one of our very good friends, and we already have a significant level of trust and confidence in each other. With the promises also given by the RC government, I'm sure such a cooperation would be plausible and doable.
Anh Long với mọi người ở VNPI với cả các anh em có câu hỏi gì thì có thể hỏi thêm họ. Đặc biệt là cái iChipBand đây không? Xem có cái vấn đề gì cần hỏi thêm. Anh bật tiếng lên, chưa bật tiếng.
Dr. He and 越南的朋友啊，
Okay, Dr. Hip, I'm a friends in Vietnam. Good afternoon. So, regarding the development programs for companies and the industry, I would say that here at CPC, we started in the early days with upgrades and moving the industry forward. Of course, you may know that the Taiwan companies moved to China after some time afterwards, and because of that, we also went to China to assist these Taiwan companies. In the recent years, however, we do see the manufacturing line and supply chain moving south towards southeastern countries. So our hands also move south to help the Taiwan companies in Southeast Asia. We currently have not provided that much assistance for Taiwan companies in Vietnam yet, or for the local companies. We've still been working mostly with the Taiwan companies in Vietnam only.
In fact, as far as I'm concerned, beginning with last year, before the outbreak of the pandemic, I visited Ho Chi Minh City in Vietnam every other month to help Taiwanese businesses there. In the course of my assistance to Taiwanese businesses, I'd like to share my observation from three perspectives with you. In Vietnam, currently there are many companies who are still lacking IT people. So I think maybe it will serve us well to look at this from three perspectives. The first is about how the information can be accurately and quickly collected. Also, when our people see the data, how capable they are in making a determination based on the data, and this kind of capability has to be enhanced. And this is about the training of people. The third aspect is about the government agencies who should make an all-out efforts to promote all the work. I'd like to go into further details based on these three aspects. For the purpose of digitization, the information has to be accurately and quickly collected and consolidated. Even in early times, when there was still no advanced monitoring or surveillance equipment, take Toyota Auto, for example. In early times, they didn't have very good monitoring equipment either. Still, they leveraged many different kinds of technologies to quickly provide the production information to decision makers so that they can make decisions very quickly. Or even the supervisors will be able to see the information so that they can proactively respond to all the relevant issues. So Whether you have very good IT systems or monitoring systems or equipment, from the perspective of Industry 4.0, these are the pillars. However, more fundamental aspects would include our people. We need to consider whether we can provide good training to our people. When our supervisors or employees or personnel cannot be properly trained, even if you have purchased very good equipment, actually the equipment cannot be sufficiently or fully successfully utilized. For example, you may have spent a budget on, for example, you have spent a lot of money buying a good race car, a sports car, but if you don't have a good driver to drive the sports car, the performance of the sports cars cannot be fully demonstrated. Or even quickly, the sports car will be damaged very quickly. So in the course of IT development or digitization, in the beginning, I think the employee training is very important. As for the current monitoring equipment, or Kanban or dashboards or visualization systems, actually, it's not very expensive to invest in such systems currently. Without the systems in early times, we use our hand recording system. We record everything by hand. That can be replaced. So we invest in such a monitoring system or visualization system. Our investment as such can help us move to the next level quickly. However, if your supervisors or employees do not go through proper training, even with such numbers or data, are they able to make a correct determination or judgment? That's a big question. So the training of employees is very important. And in the course of employee training, there are different stages that we have to consider. For example, the work ethics or the workplace ethics that the employees have. We need to also create the value systems for the employees. So for the business owners and the employees, both of them have to be educated. Secondly, there are two important tools for the development of enterprise. The first is quality. The second is efficiency. These are two very important aspects. Quality is the most important. If you don't have quality, your efficiency will not do you any good. If you are very efficient but the quality is bad, you come up with a lot of defective products. And that's a waste of our resources. So these aspects are very important. That is quality and efficiency. They are very important for the development of the company. And also in the journey, we need to begin from the fundamental in terms of the employee training. Industrial engineering, improvement, issue problem analysis and problem resolution. These are the pillars of employee training. Take Japanese companies, for example. At the end of the Second World War, in Japan, they spend a lot of time training their employees. They laid very solid foundation in employee training. And that was why Japan could grow very quickly. In 1945, when the Second World War ended, through 1973, Toyota could beat automakers in US during that period. This shows the success of a Japanese company in training their employees in the solid foundation they laid in employee training. So that's the second aspect about employee training. So my recommendation to our friends in Vietnam is that I think we should pay attention to laying a solid foundation in training. The third aspect is about the promotion or the implementation of government policies. In early times when Taiwan's quality was not recognized in the world, CPC worked with the government in promoting TQM activities for 20 years. We had 4 phases of the implementation, each phase lasting 5 years. At that time, the focus was on educating all the employees and all the citizens, all the employees of the enterprises and all the citizens regarding the importance of quality. From the cultivation of basic concepts through improvement to technologies, all the way through business management. So in early times, Taiwan government made a lot of efforts in enhancing the quality of products in Taiwan. I remember in the past, at that time, there was one occasion when we had an activity where we passed a torch from Taipei around Taiwan, a torch for TQM around Taiwan. It's passed down or travel around Taiwan as a promotional effort, a promotional activity. So I think even the government has to be innovative and creative in educating, in training business owners and all the citizens the basic concept that they should have. So I think I'll stop my sharing here. These 3 major aspects. Thank you very much. Dr. Hip asked about how we conduct training, how we help companies or enterprises. That's why I asked Mr. Liu to provide a very detailed answer to the question. Dr. Hip talked about the issue of personnel, talent cultivation, and how to set up a platform. That reminds me of what happened 35 years ago. 35 years ago, I should say in the course of my employment at CPC in the past 35 years, I remember 32 years ago, I went to ICO of Toyota. I tried to understand how Toyota developed its business. I spent 10 days there. Aichi is Aichi Ken. I didn't understand how they did it, and so later, 2 years later, I visited that place again. And I did two things after I returned from Japan.
现在回到台中，台中应该是在台湾，我们是大型的训练中心。
We have CPC has a major training center in Taichung, which is central part of Taiwan.
这是我开始建立
And then I started to establish a training program focused on two guidelines or two directions. For management category, there are four major points. The first is corporate culture, employment relationship, labor relationship, and then we provide training to employees.
第二点，我训练他们 IE
And then I train IE, industrial engineering.
第三，教出他们就
QC 改善。
Well, thirdly, I talked about QC improvements. And fourth, I taught them management and daily operations. And this allowed us to promote the new concepts, to focus on quality, focus on efficiency, and different ways to achieve this. So this was the management side. Secondly, we also started to, if I recall correctly, about 30 years ago, in terms of training education, the first PLC we used was Modicon. It was later merged, acquired by Schneider's. And then we bought from Mitsubishi and Omron's PLC, and also used them as teaching material. And at that time, we started teaching AutoCAD first to SolidWorks, Cori, StudyH, and then CAM, or Mastercam, NXCAM. And nowadays, we should move into the virtual space. So smart manufacturing of machinery is actually the latest topic in recent years. I recall that 30 years ago, I was just a trainee, and yet I started to promote the training program and work on setting up a training program. I now have 40 to 50 trainers here in the Taichung site of CPC, and I slowly built up the training center here in Taichung. So this was actually my experience and how I started to build up this entire program. So I recall Dr. Hip saying that you actually need the time to cultivate talents. I recall 30 years ago, the question I asked Toyota was, how long does it take to cultivate talents? And the answer was, you need to start from the basics. You need to give them a foundation. You have to combine a top-down and bottom-up two-pronged approach. And this is actually an endless cycle. That answer touched me. And that is what I did when I came back to Taiwan. We have a management class here in Taiwan at the highest level, up down to the skill level classes for employees. So as Director Liu has shared, this actually is work that needs to be carried out along with the government policies, since this actually has wide and comprehensive impacts. There's a saying that goes like this. Well, consultants can provide services everywhere, but if we're talking about a training program in Vietnam to cultivate trainers in Vietnam, then we need to be prudent. I recall 30 years ago, I learned from a lot of Japanese lecturers And I received this training program for trainers from Japanese lecturers. And at that time, I actually enrolled in a lot of these consultant classes, classes that taught management skills, consultancy skills. And basically, most of my lecturers were from Japan 30 years ago. But about a decade ago, most of the lecturers were from the US or Europe. So my suggestion is, or my suggestion for Dr. Hip is, what we need to do is we need to teach people how to fish and not just simply provide them with fish. We need to give our friends at Vietnam's Productivity Center the ability to teach people to fish, and not just the ability to give people fish. Of course, we need to cultivate a lot of top anglers and people who know how to fish. But what's more important, we need to make sure that they can teach people how to fish and not just know how to fish themselves. We need them to teach these companies and local enterprises how to fish. Based on my experience over the past 20 to 30 years and my observation in the past 10 years, my Japanese teachers or lecturers total to about close to 20 of them. And as I look back, I think at least 20% of my time was spent on learning these new ideas and new concepts. So, of course, I have been encouraging my newest staff to continue to improve themselves, to learn new ideas and new knowledge. As this is, as my lecturer said, it's an endless cycle. So I think I'm just using this opportunity to share my experience, myself, what I went through myself over the past 30 years. And finally, as a final comment, I recall that when I was young, in terms of consultancy skills, we talked about IE consultancy and actually enrolled in a class that took 450 hours to complete. For QC, it also took 300 to 400 hours. And of course, the classes had a huge impact on me. So I think I would just like to share my experience and what I went through in terms of training with all of you. Yeah, that's just my sharing my part and my experience for your reference.
For your sharing your experience. Yeah, it's very, very good and useful for Vietnam in current stage. Yeah, thank you. Rồi xin mời anh Long với Nhung. Bật mic cho anh nha.
Thank you for nice presentation. I want to answer about a question about the roles of productivity consultant in the Smart Manufacturing project. Is the consultant of productivity play a key role in Smart Manufacturing project still? So how to enlarge the synergies of the productivity chapter in Smart Manufacturing project? Thank you.
Regarding increasing productivity in smart manufacturing programs, it is, of course, still a very important indicator. But before we focus on increasing productivity, we need to first focus on improving quality, because if we're unable to get the quality right first, then it doesn't make sense to simply improve productivity. I would say productivity actually is an overall term that covers many aspects. It covers efficiency, quality, and lowering downtime, etc. So my comment is, in terms of smart manufacturing programs, before focusing on improving productivity, we actually need to focus on quality first. If we can improve the yield rate to 100%, then that would actually be better. That is, if the yield rate is only 80%, then improving the productivity would still give us only a yield rate of 80%, and that doesn't make much sense. Yeah, okay. If I may add something, this was actually something we've experienced as well. About 30 years ago, we rolled out programs that promoted automation, and we were able to improve the machineries, and the companies were actually able to mass produce the products quicker. However, the yield rate was low, so they did not have good practices, and that actually did not make much sense for the company, because that simply meant more waste. Okay, actually, I see a question in the chat room on what exactly is digital transformation. Let me put it this way. For the average factory or enterprise, there are basically 5 types of systems that can be used, or the 5 major categories. The first is called the commercial system, by which I'm referring to, for example, supply chains, online merchants. These are all sort of commercial models. The second category would be ERP, or enterprise management systems. The third category would be MBS, the manufacturing management systems. The fourth would be equipment monitoring systems, such as CAC, PLC, or sensors. And the fifth category is knowledge management system, such as PLM, knowledge and information management systems, or PDM, for example, product data management would also be considered a part of the fifth category. So in terms of management, the first is, of course, the transformation from analog to digital. This, of course, refers to the equipment itself. The second transformation would be on protocols, whether each device would be able to communicate using the various protocols, since the equipment may come from different eras. We have to make sure that the devices talk to each other. And that is what we call optimization. And finally, the last type of transformation is moving from smart commercial models to linkages in the entire chain. That is, the commercial side would be linked to the manufacturing side. And finally, it would be linked to our inventory and supply chain. And this would all be able to be under the umbrella of the work order and the order management system. So other than the 5 categories, of course, we also have to talk about linkages with the people, with the corporate culture. And that is what I would term digital transformation. The Porsche company in Taiwan, the Porsche in Taiwan, the branch office, you would see that each and every Porsche is actually customized for the customer. Every Porsche that rolled out is customized, and they have to do this, otherwise the customers would not buy in. So I hope that answers the question on what is digital transformation.
I have one small question. So you know, in Vietnam, our machinery and also device is very low technology and very old. We don't have new machine and technologies. So do you have some recommendation for Vietnam smart to implement smart manufacturing based on this very old system? Yeah. Thank you.
哎，
This is a gentleman from Siemens, and now we have our engineer here. These two gentlemen previously worked for Schneider. I think this question maybe is appropriate for these two gentlemen. So I think there are two categories. Strictly, there are three categories. The first is a single chip monocon, monocontrol, and the second is PLC control, and the third is CNC control. For old systems or legacy systems, how do we deal with this kind of issue involving legacy systems? Why don't you start first? Dr. Heap, good afternoon. Regarding how to deal with old systems, how can we create a digital system, digital information, a digital signal? Oftentimes, equivalent vendors may not have machines that have PLC or controllers. Now, regarding PLC capable machines are newer systems. First, we need to see if the machine has communication capability. And we don't need additional sensor. And then through the PLC sensor, we can obtain information to SCADA and also feed the system information to our computer system. Because in order to digitalize, we need to have a database. And the database then will have to be linked to MES and ERP for digital transformation. When our equipment does not have controllers, maybe we can try to obtain some digital signals for a particular industry. You may have some kind of foot pedal, and you may have a digital signal, and we can come up with a new PLC system, and then you can try to obtain the signal. If you don't have this kind of a signal, maybe you can make good use of the sensors. You can set up sensors in order to then you can have external connection with PLC and combine with sensors to get the information or the signal. Regarding CNC, it's more difficult because older machines are more close-ended. And then you need to have sensors. You need to create sensors, you install sensors. For new CNC machines, they have communication capabilities. Then you'll be able to directly extract information from the machine for digital transformation. So that's my recommendation. And this gentleman is an engineer at CPC, and he is in charge of the design of many sensors of our teaching tools. But CNC is more difficult. Now, our instructor from Siemens. There are two very important points. The first is the information integration within the machines and also integration external to the machines. When you set up a machine, you need to have a power system. You need to have a control system. In the past, you may use a general counter or relay. You'll be able to make the machines work. However, in the course of digitization, we want to reduce the wiring needs. And then we gradually use PLC and as part of automation effort. However, in the course of assembling different components involving PLC, we also use communication, take the communication integration approach. So in the transformation process involving the machines, we need to think about ways where we can gradually reduce the wiring needs of the machines so that we'll be able to focus more on the collection of data. For example, for traditional motor or sensing motor, in order to control that, you need to use a frequency variation device. And you need to use a traditional wiring approach. However, in the digital era, we use a network approach. That's why we need to use Ethernet or communication protocol to integrate that aspect. So it's more like integration within the machines. So in the course of the development of machinery, for the vendors, if they want to sell the products, they will need to digitize their products. However, if you are an operator of the factories, you purchase machines from different suppliers. After that, you need to set up a situation room with all consolidated information. Then you need to consider the aspect of information integration outside of the machines. So in that context, you need to consider a standard data collection approach. That's why you need to set up a specification. If you just want to collect data without setting a standard communication specification, you will come across the issue. For example, for the first year, you need to consider the integration needs of Siemens equipment, but later in the future, you may purchase equipment from Mitsubishi, and then you need to try different integration efforts to integrate Mitsubishi machines. So if you don't have a standard in mind, you will be surprised that each year you are spending money doing the same thing year by year. So in the course of digitization, whether you're talking about new machines or old machines, you need to come up with the standard first, the communication protocol first. That is, I try my best to make my legacy system and the new system to be compatible with the system. The Machine Tool Association in Taiwan 2 years ago, in 2018, they made an announcement. The communication protocol is called OPC-UA for all the machinery. So regardless of the machines provided by different branded companies, at the time of the data collection, there is a certain way of data collection. For legacy system, you need to find a third-party gateway provider. Trying our best to convert the data from your old system to OPC-A compliant data, so that the system can treat all the data uniformly and collect the data. If we work further down, then we can look at the aspect of controllers. So when you are at the level of controllers, the most difficult issue in terms of integration is that we cannot determine the communication protocol because the communication protocols are dictated by branded companies. If you use Siemens equipment, they use OrthoNet communication protocol. If you use Mitsubishi's equipment, use CC-Link IE communication protocol. For users, you need to understand what kind of controllers you are using, from which vendors. Then you may be, somehow controlled by or constrained by the communication protocol. Still, we can identify the basic communication protocol, which is called Modbus PCP. So whether I use PLC from whatever branded companies, you can require that I want a general standard to be created that is called Modbus PCP. In Taiwan, AUO is 4 years ago, they had a big data program, because I think they have a lot of equipment accumulated over 20 years. In order to integrate data, they have come up with a standard, which Modbus PCP, so that their central supervisory station will be able to collect data from all equipment, whether the equipment is old or new. There's no difference. They don't need to worry about that. So if you are in charge of equipment, you need to do your very best to convert your old equipment so that the data will be compliant with the Modbus PCP, so that you can collect the data digitally. So in the course of digitization, you need to consider a network integration within machines, and also you need to consider network integration outside of the machines. Whatever the case, you should have a standardization. You should begin with standardization in mind, and before you can make further improvements, so that you don't have redundant investment. Mr. Chen and Mr. Lai have responded to this question. They indicated that for all systems, Mr. Chen talked about Modbus. That was communication protocol for automation. For OPC-QA, is new. It covers control, communication, and information. And a lot of companies have participated in such a protocol. 10 years ago, for CNC that are more than 10 years ago, it's more difficult to deal with. For younger CNC machines, it's probably easier to deal with. For old machines, Japanese machines are more cumbersome, and European ones are easier. For Siemens, it's easier to deal with these systems. Mitsubishi and Funaki, they use closed-ended systems. I think I'll stop here.
I think to deal with the old system is one of our country, how to say, requirement to show that issue. Yeah, and we need the support from CPC and Siemens in the future. Yeah, very near future. Siemens have the office in Vietnam. Okay.
有办事处。
Yes, Siemens has its office in Vietnam.
Please introduce VMPIs with the Siemens, so we will also have some further discussion. If it is possible, yeah.
Actually, Siemens has after-sale offices in different countries, in different parts of the world. Because they want to help they want to support local customers with respect to upgrade of legacy machines or to develop new projects. Actually, I think they have their branch offices handling that. As to the contact information, I will ask Linda from Siemens to provide the contact information about the offices of Siemens in Vietnam to our moderator, and the moderator will provide information to our friends in Vietnam. Let me provide additional information for machines in Asia. You have more machines produced by Fanaku or Mitsubishi. I don't know about the situation in Vietnam. For Japanese controllers, I think early on they were closed-ended systems. Here's my recommendation. In Taiwan, for standard machines such as, for example, machine tools or mold injection machines, they use hydraulic system instead of CNC. For servo machines, they use CNC. The government in Taiwan retains some companies to create smart boxes collectively to deal with this issue, to address the legacy system issue together. So don't, I think it's very important to concentrate your efforts. The government can assign maybe a few number of companies to work on this issue. The government can provide a budget to them. And then the government can sign the contract with them, and if they are successful, they cannot charge R&D cost against these companies that need their services. They can only charge the installation cost. That's my recommendation.
Okay, thank you very much. Understand, yeah. Okay. So any comment and questions from VMPI? Mai ơi, Mai xem có cái câu hỏi nào từ phía doanh nghiệp mà qua cái YouTube không? Mai với cả Nhung ấy, thì có thể đặt câu hỏi cho họ. Nếu mà có 1-2 câu hỏi gì đấy. Hỏi họ. So can we have the one questions from VMPI? So they collect the question from the enterprise. They follow us via YouTube. Rồi mai Vinh Nhung có thể hỏi giúp anh 1-2 câu nữa cho họ.
可以。
Sure, no problem. Of course, we can answer questions from local enterprises as well.
Yeah, thank you.
One question that, according to experience in Taiwan, should we separate two concepts, digital transformation and smart manufacturing for enterprises?
Okay, can you please speak up louder? We cannot hear the question. Apologies, this interpreter, we cannot hear the question.
Yes, can you hear us now?
Yes, loud and clear now.
Thank you. According to experience in Taiwan, should we separate two concepts, digital transformation and smart manufacturing, for enterprises that do not have a digital transformation platform and have no preparation for smart manufacturing? What is the roadmap towards smart manufacturing, and what is the reasonable way to do it? That's our question.
Okay, allow me to take this question. I believe they're actually the same thing. Digital transformation has a broader definition. It actually covers a wider scope. But for smart manufacturing, we're actually talking about meeting the company's demands or needs. If I'm an OEM, for example, just to give an example, let's say I am an OEM for Nike or Adidas. They would, of course, not want me to communicate with clients. So I can just focus on smart manufacturing. I don't need to interface with clients. I may have my own channels. And only when I have my own channels do I need to work on the client side. For example, if I am an ODM instead of an OEM, then I will need to work on customer management. So digital transformation actually covers the commercial side, the interfacing with clients. But if you take out this interfacing with clients, then it's just smart manufacturing. So my take is smart manufacturing plus a smart interfacing with clients would be digital transformation. I'm not sure if Siemens will agree with my definition, but let's hear from Siemens. Let me share our viewpoint. Well, we believe that digital transformation is just a concept. So if it's just a concept, then it actually disregards which area you're talking about. We're not just saying the manufacturing industry needs digital transformation or a certain industry needs digital transformation, but rather digital transformation is needed for the entire country. This would even cover the primary education for students. That is, if we're using iPads in classrooms for primary school students, then this is also a form of digital transformation. So when digital transformation is implemented in different fields, then it would take on different forms. If digital transformation is carried out in the manufacturing industry, then we call it smart manufacturing. If it's carried out in logistics, then what do we call it? If it's implemented in a car manufacturing industry, then that's smart cars, smart vehicles. And if in the logistics, it's smart logistics. So for us, digital transformation is just a concept. And the purpose is to upgrade the industries of a country. That's why we call it a concept. And of course, certain industries would move faster than others in terms of digital transformation. To use a Taiwan example, the electronics industry actually is moving the fastest in terms of digital transformation, whereas the agriculture sector moves the slowest. However, they are both engaging in digital transformation. We would not say that, oh, digital transformation is just for the IT industry and not for agriculture. That's not the case. The agriculture industry or sector can, of course, engage in digital transformation. They're just moving more slowly in comparison. So if we can have the idea that digital transformation is a concept, then it's actually an idea that should roll out for both the upstream, midstream, and downstream. It's actually a concept that people need to have in order to communicate with each other, and that's actually the purpose of this transformation. If the people in the upstream, midstream, downstream can talk to each other, if the devices from these companies can talk to each other, then that's digital transformation. And that is actually one of the goals of Industry 4.0. That's the kind of world that Industry 4.0 wants to create. I actually fully agree with the experts from Siemens. I think his definition is actually broader than mine. I recall when I last visited Vietnam, we talked with Dr. Hip about smart cities and smart livelihoods. I think that is the digital transformation from a bigger picture. And if we put this in the manufacturing industry, then that's smart manufacturing, and that applies to different industries. That's when we add the word smart in front of it. So basically, these are all under the same concept. So my previous suggestion was just the 5 categories in the manufacturing industry, and do not mean to use that to define digital transformation.
Ai xem còn câu hỏi nào nữa không?
Dạ không anh ạ.
Anh thấy có anh Long có câu hỏi gì về liên quan đến iBand đấy và về cái ấy đấy thì Long có thể trao đổi thêm với họ đi. Nốt câu nữa đi.
Không có.
Thế à?
Anh hỏi em câu vừa rồi.
Xong rồi gì?
Xong rồi.
Okay. So any questions from other member?
Chị Nhung có hỏi không? Chị Nhung có hỏi về kho không? Dạ thôi anh ạ. Không còn.
Okay. Okay, maybe at the current stage, so no question anymore. So if in the further stage we have the question, we will send you by email. Yeah, and also before we finalize this discussion, so I have just maybe my comment on this after this meeting. So for Vietnam, maybe we will focus on such kind of how to say to connect together the data from our system and try to utilize this data, because our system is not new and we will have the diversity on the machine. Yeah, and that such kind of technology, such kind of solution should be very, very important in Vietnam in current stage. And the second, I think, so from your presentation, so we can, how to say, focus on the human resources. Yeah, and I also discussed with VNPI, so maybe we will set up such kind of project to send our expert to CPC or other partner in Taiwan to study about smart manufacturing. Similar in Taiwan, you send the people to Japan 30 years ago, right? To learn in Japan. So I think the knowledge is very important for Vietnam. And VNPI will prepare such kind of project for our ministries. And the third, I think, so because Taiwan enterprise solution have many solutions for SME. So recently, VNPI, we signed the MOU with the Vietnam SME Association just last week. We signed the MOU. Yeah, so in Vietnam, the SME account for 97% in Vietnam, and we have the very close cooperation with them. So I think if it is possible, VNPI and CPC can work with the Vietnam SME Association. Yeah, and then we can take some surveys with them, and then we can select some SMEs in that association, and from our ministry we can try to perform some demonstration project for them to do the transformation. So is it okay? How do you think? Our next step, yeah.
I think this is definitely doable. Well, in the past, we learned from these Japanese lecturers and would be more than pleased to share what we've learned as well as the experience we accumulated over the past 40 years with our friends in Vietnam. Since we're the Center of Excellence on Smart Manufacturing under APO, it is our duty to share the knowledge with other member countries. So this is definitely doable.
So from VNPI, you have some comment and Long? Anh có nói comment gì không anh Long ơi?
Không ơi.
Cảm ơn. Cảm ơn họ cái.
Thank you so much, sir.
好，我想
Okay, then we look forward to the pandemic closing its curtains. I see the vaccine coming out in Q4 at the earliest. So for next year, I wish you all good health and prosperity. And I do look forward to meeting Dr. Hip again in Vietnam. And I look forward so very much to receiving our friends from Vietnam again in Taiwan. Once again, I wish the very best for Vietnam and for all our friends at VNPC.
For finish the meeting, just I have a small comment for CPC, right? Okay, in November, so we will organize the meeting, APO ASEAN meeting. So this year Vietnam is APO chair of APO. Also Vietnam is the chair of ASEAN. So our initiative, we will organize the meeting between APO and ASEAN, and we will, how to say, transfer the smart manufacturing concept from the APO to ASEAN. So in that case, we would like to invite CPC to join that meeting with us. Of course, it's virtual meeting, yeah, and to share our activity, yeah. The detailed plan, VNPI will discuss with CPC, yeah, via email. Thank you.
好，那
Thank you very much, Dr. Hip, for your recommendation and invitation. We will be pleased to communicate further via email with our liaison officers at APO. And if the focus is on smart machinery, then I will be bringing forth our team of experts for the presentation at the meeting. Thank you for giving us this opportunity.
Okay. Okay. Thank you very much for your support today. Yeah. Hope to see you next time. Yeah. Okay. Bye bye.
谢谢各位哈。